Okay, part A for question number 6 on the 2009 FRQ. This part of the question is fairly simple and just requires you to look at the graph of f prime and find where it's increasing or decreasing to increasing. And basically the points of inflection occur when on the f prime graph it goes from increasing to decreasing or decreasing to increasing. So one of the points of inflection is at x equals -2 because the graph of f prime changes from decreasing to increasing. And then the other point of inflection is at x equals 0 because the graph of f prime goes from increasing to decreasing. So you're left with 2 points of inflection. The grading for this part of the question, it's worth 2 points. One of the points is for identifying the actual points of inflection, and then there's 1 point for justifying your answers, which basically all you have to say is that on the graph of f prime, it changes from increasing to decreasing or decreasing to increasing. Okay, part B for question 6. So you have to find f of -4 and f of 4 using the piecewise function that he gives you. So to find f of -4, you would use the equation g of x. So to find f of -4, you would find the integral from -4 to 0 of g of x and set that equal to f of 0 minus f of -4. So in order to solve for f of -4, you would move things around and then you would get f of -4 equals f of 0 minus the integral of -4 to 0 g of x. So then in order to solve for this, you would plug in 5 for f of 0 because it was given. However, you can't really plug anything in for the integral of -4 to 0 of g of x. So in order to find values for the integral of -4 to 0 of g of x, you would have to use geometric figures given by the graph of f prime. So looking at the graph from -4 to 0, you can make a rectangle with a width of 4 and height of 2 to give you 8. And then to subtract the area above the curve that you calculated by using a rectangle, you would subtract 2 pi because the formula for semicircle is pi over 2 r squared, which would give you 2 pi. So then the values you would be plugging in to find f of -4 would be 5 minus 8 minus 2 pi. So in the end, you would end up getting 2 pi minus 3. So for your final answer, you would get, so your final, so for your final answer, ah, so for your final answer, you would get 2 pi minus 3. So now you need to find f of 4 for the other part of part B. In order to do this, you have to use the other part of the piecewise function. So you set an equation of the integral of 0 to 4 of f prime of x equals f of 4 minus f of 0. So after you move things around, you can get f of 4 equals f of 0 plus the integral from 0 to 4 of f prime of x. So now that you've set up the equation, you can start plugging things in. So you get 5 plus the integral from 0 to 4 of 5e to the negative x over 3 minus 3. So in order to take the integral from 0 to 4 of 5e to the negative x over 3 minus 3, you'll need to use u sub for the first term, which you will end up getting negative 15e to the negative x over 3. Then for the second term, you'll get negative 3x. Now that your equation is set up, you need to evaluate the equation from 0 to 4. After evaluating it, you should end up getting 5 plus negative 15e to the negative 4 over 3 minus 12 plus 15, which ends up being 8 minus 15e to the negative 4 thirds. As for the scoring for this problem, it's split up into two parts. So the first part is finding f of negative 4, which is worth 2 points. You have to have the correct integral and then the correct answer, which is 2 pi minus 3. Then the second part is to find f of 4, and in this you also need to have the correct integral. However, this one you need to have the work for the antiderivative, which you didn't have to have in the last one because it was using geometric figures. And then the last point awarded for f of 4 is the final answer, which is 8 minus 15e to the negative 4 thirds. For the last part of this problem, you have to find the value of x at which f has an absolute maximum, and you have to justify your answer. So in order to find the maximum value of f, you have to look at the graph of f prime. Since the graph of f prime tells you when the graph of f is increasing and decreasing, you can see from negative 4 all the way until 3 ln 5 thirds, which it gives you as an x-intercept, it's increasing. And then anything after 3 ln of 5 thirds, it is decreasing. Using this information, you can conclude that it reaches its maximum value at 3 ln of 5 thirds because that's where it stops increasing because the slope becomes negative after that. So as your answer, the maximum value is at x equals 3 ln of 5 thirds, and you would just state that from negative 4 to 3 ln 5 thirds is increasing, and from 3 ln 5 thirds to 4 it is decreasing. Therefore, it must hit its maximum value at x equals 3 ln 5 thirds. As for the grading for this part of the question, they give 1 point for the correct answer, which is x equals 3 ln 5 thirds, and the justification, which is where it's increasing to and when it starts decreasing.